We're live, VMworld 2014 in the Hangout space. I'm Vaughn Stewart of Pure Storage here on the community stage powered by vBrownbag. I want to share with you some storage topics and conversations. Storage is obviously a hot topic here at the show. Lots of innovation going on, lots of new options for everyone to look in their storage platforms. And I want to kind of divert a bit. I don't want to talk product, I don't want to talk technology, I don't want to talk protocol, right? I don't want to talk pros and cons. How about 10 surprising things that you may or may not know about flash storage memory? Is that fair? So, I had a lot to learn as I transitioned my career from a spinning disk vendor into an all-flash vendor. I thought I knew storage. I didn't know much about it at all. And as I look at my peers sharing their thoughts about flash, I hear a lot of conversations around, hey, flash is 20 times faster than disk. True statement. But there's so much more to flash. So let's dive into this a bit. I'm going to try to make this fast. I hope you find it entertaining as well as informative. But like all vBrownbag sessions, post comments, post your feedback, and if we needed to fill this out more online, I'll write a guest post and we'll put it up on the vBrownbag. So let's start. 10 surprising things you may or may not know about flash memory. Number one, flash storage can write data to any zeroed out cell. Oh, I messed that up. Flash writes to any zeroed out cell, but can only erase at the block level. And a block level is a collection of cells. So very granular writes, but very macro erase cycles. That's very different than disk, where you can write to a block and you can just overwrite the block, erase the block, right? So it's a different behavior and characteristic of the memory. Number two, blocks must move any valid data in them to new cells in order for the block to be erased. This process is called garbage collection. So think about as you write data to this very granular level and you delete some and some gets overwritten, it ages over time. For me to actually get free space back in the device, I have to take the remaining good data or valid data, move it somewhere else, erase the cell. Again, a very different behavior than disk storage. Number three, and I said this on number one, flash doesn't write data. It programs data. A little different terminology than we're used to, where we're used to reads and writes, right? We're going to talk about programs. This is memory, not disk. Number four, there are different levels of voltage required to execute a read, a program, and an erase on a flash device. Now that may make sense to you, but you need to understand that, take that one step further and understand that a block of flash can only have one of those three operations occurring on it at a time. So you can have flash and think it's 20 times faster than disk, but as you build an all-flash based array, understand that you can have I/O contention if you need to read some data that's in a block, right, from a certain set of cells, at the same time that you need to write to cells or overwrite cells that are in that block, right? So you need to look at architectures that prevent you from having I/O contention, I/O blocking, I/O bottlenecking, whatever the term may be. Plenty of vendors out there are going to tell you about what they do. Just be aware that this is something different than disk. Number five, flash resiliency ratings, right? How many of us look at flash resiliency and we go, how many write cycles can this drive sustain over the day? And what does that mean in a year? And when does it wear out? Am I buying enterprise grade? Am I buying consumer grade? What does this mean? What you need to understand is that flash resiliency ratings are based on write amplification. And write amplification is what I was talking about in number two. Remember that you wrote some data and you got to move it around later so that you can always free up space within the drive? That process of garbage collection equals write amplification. The industry, the flash industry, uses a metric of 8.6 as an average write amplification factor, meaning over the life cycle of the device, each bit of data will be moved or thus amplified 8.6 times. Right? Again, something very different than disk. Disk, you usually write data, and if it's not deleted, it's very resident. It sits there. So item number 6. So here's some secret sauce that any of the all-flash vendors may want to talk to you about, and where some of the times there's a significant distinction between flash systems built from scratch or from ground up versus putting flash into a storage array or into your laptop. Reducing write amplification through technologies like data reduction and zero-cost provisioning, data reduction, actually increases the resiliency of flash memory. In other words, if your device said it could sustain 20,000 writes a day, a write amplification of 8.6. What if you could reduce the write amplification to 1? Now how many writes a day can you sustain? Basically 8 times more than what the device is rated for. So my point to this here is understand that these resiliency numbers are focused around treating flash like disk, which is the worst way you can treat the device. Number 7, every all-flash array includes some form of swap capacity. Now, it could be in the drives themselves, or it could be in the system. This is called over-provisioning as an industry standard, but this swap space helps compensate for the failing of cells over time. This helps raise the resiliency rating of drives, again, based on that 8.6 write amplification number. So just know that when you're looking at a drive, if it says enterprise MLC, it probably has somewhere between 25 and 200% over provisioning. And if you're buying consumer grade, it means you have 7% over provisioning. Those who usually use consumer grade put additional over provisioning in their systems. Those who use enterprise grade, just let the drives handle it. Right? Just understand what you're paying for in terms of capacity flash versus usable. Number 8, flash is actually more resilient than disk, and most crashes of flash is based on SSD controller firmware issues. And most all-flash arrays simply power cycle the device, and it just resets the device and it's online. So technically you have crashes, but you'll never see them as an end user, right? Data protection mechanisms and the systems that can just reset the device allow you to have greater availability than what you're used to with disk. Number 9, all flash arrays are metadata based. They're basically objects, right? Today, most all flash systems allow you to have block-based access. It could be iSCSI or fiber channel, but understand that these are just objects. Everything is metadata based. We defined a collection of cells to represent an object, access protocols, ACLs, etc. It's completely object oriented, and there's a lot more flexibility in these all flash systems today than what you have traditionally with disk, which probably allows these platforms to really grow over time to address different types of workloads. And number 10, and I'm sorry that the fonts are off here. I didn't have my brand approved font loaded in the system. I'm going to take a smack on the wrist for this. But flash consumes 1/6 the power of a disk drive when active, and more importantly, less than 1/20th when idle. I surprise a lot of folks when I share with them that over half of my conversations with customers have nothing to do with performance. That has everything to do with data center resource contention, rack space, power, cooling, right? We are having conversations in the industry today around how many watts of power per gigabyte does it take to run your system. These are conversations around the advancement of storage. We live in the information age. Data is growing, leaps and bounds year over year. We've got to store more in less, and less not only means rack space, but also power and cooling requirements. So with that said, I want to thank the vBrownbag team for having me on stage. I hope I shared some neat trivia items if anything was taken away from this. Please, if you'd like to talk more about flash, and again, whether it's product or just industry trends, stop by our booth. We're here, Pure Storage at VMworld, booth 1613, and I'm giving up the stage to the next presenter. Thanks.